Hello world, DinoMega here.
In this video I'm going to walk you through integrating version 3 of my inventory system and version 1 of my experience system into version 2 of my quest system using its new connected systems BPI. Through these systems we'll give our player quest rewards for completing our quests, and we'll also set up using them for our prerequisites. Finally, we'll resolve a few overlapping issues related to input. Now as for our starting point, I'm going to be continuing from where we left off in the working in blueprint video, but we will be working in the quest system's demo world since it has a lot of the quest parts already set up and ready to go for us. At minimum, you'll want to have completed the installation and setup video. If you are continuing from the working in blueprint video like me, I do recommend deleting all the events you created inside the blueprint. This is because some of these key bindings we are using here overlap with ones used by the systems. Now you can duplicate a controller, then in the original one that is used by your game mode, delete the key bindings there. That way you still have a copy of it to use as a reference if you need it going forward. Navigate to the quest system's demo maps folder and open up the map_quest demo world. Then from the world settings panel, change the player controller to use the one we created previously, our BP_third person controller. Press play and right away you should see a notice about our connected systems not being set up. And this notice is actually occurring because in our demo world we're using a custom prerequisite for the on-off light example. So it's kind of expecting us to provide instructions on that. And it does this through our connected systems BPI, which we currently don't have on our controller. And this is why we're seeing that error. Head back to your player controller, then click on the Class Settings button. From the Details panel, locate the Implemented Interfaces section, and then click the Add button. From the list, select BP_Quest_Connected Systems. When you do, it'll add this Interfaces section on the left, and if you expand it, you'll see all the functions it just added for us. These functions are what the Quest system will be communicating with to interact with your systems. And we'll be working in these top functions today, and the bottom three Get My functions we will not cover in this video, but if you'd like to learn more about them and their purpose, see the Connected Systems page in the documentation. Before we dive in, give your demo world a try, and you should see that notice we saw previously is now gone. But if you do still see it, you're most likely not using the right player controller for the level. Review the world settings to fix it, and don't continue until you resolve the issue. Now we're ready to start working with our inventory system. From the Epic Launcher, locate My Inventory and Item System in your vault, and then add it to your project. Take a moment to verify that the inventory system is in your project. Then on your player controller, add the AC_inventory item system component to it. This will install the inventory system. And you can confirm by pressing play and verifying that the inventory does work when you press the I key, and that the hotbar is visible at the bottom of your viewport. You may have noticed when you interact with the quest giver that the item system shouts that there's nothing nearby to interact with, even though our quest window opens. We also have this issue where if we have the inventory open and a quest window open, and then close one or the other, we lose our mouse and our input. These two issues are because the two systems are overlapping in these two areas. Let's resolve them before we jump back to our integration. And first, let's start with our interaction. The way we solve this is by combining the two interactions together. And in this case, we're going to handle this inside our player controller, since that's a good place to do something like this. Open our AC_inventory item system in the item system's blueprint components folder, and navigate to the key bindings event graph. In here, locate the interact event. This is where the item system starts the interaction process. And there are a few different things going on here. The good news is we don't have to understand what is happening, because what we're going to be doing is working from the input end. And all we need to do is replace our started at and completed at execution paths with new events that we call interact start and interact end. What we're going to do is call these events when we need to from our controller. And you can leave the input action here, just make sure it stays unhooked. And if you decide to backtrack, it'll be handy to have it nearby. And since we're rebuilding our interaction event inside our player controller, we also need to disconnect our interaction event for our quest system. And this is located in the UI_quest system HUD's event graph. Locate the interaction event in the input routing section. And for this one, we don't need to make a custom event. We can just disconnect it. Next, we need a way to initialize our interact key. And since we have one right in our face from the quest system, I'm just going to copy this one and let's paste it back in our controller. Now you don't have to use this event, I'm only using it out of convenience. You can just as easily make one of your own or make a generic key binding. You can even use the input action that was made for the item system if you prefer. The point of using it is to initialize our interaction event, and we're going to control what happens next. Drag a reference to your AC_inventory item system out into the graph, and then call the interact start and interact end events that we created from the started and completed nodes of our input action. Press play and give your interact key a try. You should see our notice from our inventory system saying that there's nothing nearby. If we try to interact with our quest giver, it won't work. And that's because we haven't connected that side of the system yet. So let's do that now. Disconnect the started path and move down the inventory system interact events to make some room. Then drag out a reference to our AC_QuestSystem_Player controller, and then from this reference call the shouldExternalInteract function. This helper is made exactly for this purpose, and what it will do is try to interact with the quest system if it can, and if it can't, it will tell us it's safe to continue. And it does this using the boolean on the return side of it. Plug this in at the start of our started path, and then on the other end of it, hook up a branch. And if it's true, we want to run our inventory's interact start event. So what we're doing is continuing with our inventory system interact event if we do not satisfy it with the quest system. Press play and give it a try. You should not see the warning that we have nothing to interact with when we interact with our quest giver, and the quest window does open. Just to be safe, let's drop one of our blueprint interactable items into the level and give it a row name of loot_box. Press play, run up, and try to pick up the item, and you should be able to do so pressing the same interact key. Now this should confirm that the inventory system and the quest system are not behaving when it comes to our interact key. Next, we're going to resolve the issue with losing our mouse cursor and input when one of the windows closes, while the other is still open.
Now, in an ideal situation, we would have another component that we use to manage our widget stack and check in and out each of our widgets as needed, and this component would then manage our mouse and input mode. However, this is not something that is included with these assets, and there's no guarantee you are handling it this way in your project. So while it is not the most ideal situation, what we are going to do is handle it manually within the system, since doing it this way will have no other requirements. Let's start with fixing it in our quest system windows. Head back to the UI_QuestSystem_HUD, and under the quest helper section, locate and open the hasAnyOpenUI function. This function is how the quest system detects and manages if there are any open windows related to the quest system. And from this, it manages toggling our mouse cursor and our input mode. And what we're going to do is make sure it also accounts for any windows in our inventory system. And we're going to work out of this area in the bottom that I've already set up for you for this specific purpose. So to do this, we need to get a reference to our AC_InventoryItemSystem component that we have on our player controller. And we can use the getComponentByClass function to do that. Then select our AC_InventoryItemSystem from the list. Then from that reference, we get our item system HUD, which is called UI_ItemSystem. And inside there, we can call the getWindowsUsingMouse function, which is similar in purpose to our hasAnyOpenUI, but is for the inventory system. Hook the any pin up to a branch, which will be true if any windows are found to be open in the inventory system. Hook this up to the reroute node that is here as a placeholder for you. Coming out of the true branch, create a return node and set its value to true. Now it is important not to just hook the any pin up to the return, because we may want to continue in the future if it is false with checking some other system. This is why we use the branch here. And if we try it out and open our quest log and then our inventory and then close the quest log, we see our mouse and input are still valid for our inventory. And this is what we just resolved. Now we need to do the same thing but for the item system side of the issue, because if we have both open and close our inventory first, we still have the underlying issue. Basically what we're doing is accounting for all our widgets that are using the mouse cursor and input in both locations. And this is why ideally it's better to use a component to manage everything like this. That way these other systems don't need to know about each other. Back in our hasAnyOpenUI, double click on the getWindowsUsingMouse function we added. This will open up the UI item system and this function. And this is where we need to do a similar change, but this time we're going to check to see if any windows are open in our quest system. Copy or create a new getComponentByClass coming out of a getPlayerController node. Then from the list, select AC_QuestSystem_PlayerController. Controller. Next, from the return reference, drag off and get the quest HUD reference. From this, drag off and call our hasAnyOpenUI function. Then hook its return up to a branch that we connect to the sequence running everything else. We also want to make sure we disable includeExternal on our hasAnyOpenUI call at this point, since leaving that on will put it in a loop, since when it's true, it's actually calling this function that we're in right now, which is checking this function. So make sure includeExternal on our hasAnyOpenUI call is false in our getWindowsUsingMouse function. Then coming out of the true pin, we just want to hook it up to our incrementer like everything else. If you press play and give it a try, all windows from both systems are now getting along and behaving. And now that we have resolved the two overlapping issues between the systems, we can head back to the fun parts of integrating our item system with our quest system's connected systems BPI. The first function we're going to start off with is the one that gets our item related info, like name, description, and icon. When we interact with our quest giver, one thing you may have noticed is that our rewards are empty. And it's not because this quest has none. If you recall from playing in the demo world previously, it does. And we can see the rewards in our data table. The reason we see nothing here now is because we're not returning any data for the quest system when it asks for the item related data. And it asks for this data using the getItemForQuest function it added to our controller when we added the interface to it. Now let's start off by creating a getItem function call. This function is part of the item system's global function library, which is why we're able to call it from here without any sort of target. Let's then break our item output from this function, and this reveals just about everything we need. So let's go ahead and hook up the item name, description, and icon. For our isValid return, we can hook this up right from our function call.
Next, we have our player current quantity. For this, we need to get a reference to our item system, and then from it, get our AC main inventory reference. This is the component that stores everything related to what's in the player's inventory. From this, we can just call our getQuantity function, and providing our item row name, this will give us the player's current quantity. This quantity data is not part of the window, but it is used for the turn-in objective. Now when we press play, we still don't see our items, and this is because the ones in our data table don't actually exist in our items table. So let's open up the items data table in the item system's blueprints variables data tables folder. And instead of our sword, let's set it to Timmy's egg launcher. We also don't have heal potions or mana potions. So I'm going to change these out for our loot_box and loot_box_extreme. And I'll show you how to do experience rewards later in this video when we hook up the experience system. And reputation is one we're not going to do, so let's change this to currency instead, since our inventory system does include a currency system. And we can just set it to use our gold_coins with a value of 100. Now when you press play and open up your quest log, you should now see your item icons for our rewards, and when you hover over them, you'll see the name and description. And we can actually change what tooltip widget is shown here when we hover over the item. And this is through the tooltip widget return node. And since our item system has its own tooltips, let's go ahead and hook that one up instead. Go ahead and make a create widget node and select the UI_inventory item info blueprint. For the inputs, hook up the item row name and also the source, which is our AC_main_inventory. Then from the return of this create node, hook it up to the return of our function. Now for multiplayer, there is one special consideration we have to account for, and that is that we shouldn't try to create widgets from the server, since they are something specific to the client. And this function is called from the server as a way to validate the player account we are returning here. And since this tooltip is something that is only used on the client, we need to account for it in both use cases. And what we need to do is check to make sure we are actually running from a local client before we attempt to create the widget. And we can do this using the isLocalPlayerController function hooked up to a branch. And if it's true, we create the widget, and if it's not, we don't create it, but we make sure to continue past it. Press play and check out quest log or quest window. You should now see your item system tooltips when you hover over an item. Now we won't get our rewards as an items when we complete the quest just yet. This is another function we have to set up. Before we move on to giving awards, you may have noticed that our gold reward was not shown in the window or quest log. This is because, like our getItemInfo, we also need to set up how we want the quest system to get our numeric rewards, like experience, reputation, and our currency. And we do this in the getNumericInfo function. So open that one up in your player controller. For this one, we only need to return a name and to signal that it is valid. Now the numerics come in different forms, so we need a way to determine which one we're actually working with. And we use the numeric quest reward type enumeration to do that. From it, drag off and select switch. This will show us all the possible options. For right now, we're just focusing on currency. When we come back to add the experience system later in this video, we're going to use this switch. Now since our currency system is built into our item system, we can just call our getItem function again to get our currency data. Hook it up to the switch, break the item, and hook up the name to the output. And then set is valid to the output of it from our getItem function call. And that's all we need to do to hook up our currency numeric. When we press play and review our quest window, we now see our gold coins. Let's move on to giving our rewards, which we handle in the giveQuestRewardToPlayer function. As you can see, we have our item row name and quantity. But keep in mind, we are also handling numeric rewards in here, which is why the reward type enum is also provided. So let's make a switch off of this, just like we did in our getNumericInfo function. Since we are hooking up our item system, we can perform the exact same code for our item options, as well as our currency. And all we really need to do is call our addInventory function. So I'm going to combine all three of these into one root that we use. Next, drop in a reference to your AC inventory item system, and get your AC_main_inventory reference from it. Then from there, call the addInventory function. Let's connect it to our return node and make sure we enable handled. Also make sure to connect it to the reroute node. Our item row name and quantity are provided to us as inputs on this function, so let's plug those in. One thing to keep in mind is this function will be called once for each reward. Rewards also have a way to pass custom data through, which we can define in our quest data table and then use here to add to our items. This is more of an advanced topic, so we're not going to cover it in this video. Press play and give it a try. If you need to reset your player, you can use the giant red button behind where you started. This time when you complete the quest, you should see all three of your rewards come in. The reward that we picked, as well as Timmy's egg launcher, the guaranteed reward, and we also received our 100 gold coins.
Hello world, Timmy here. Just a little post-production note. If you need them, you can find all the UI related assets for the rewards in the UI's quest window quest rewards folder.
Thanks, Timmy. Next on our list is the removeItemForQuestObjective function, and this is used by our item turn-in example. When the player clicks the button to turn in the item, if it's handled, the quest objective will be marked as complete. But before we begin, we need to change the quest in our data table to require an item we actually have,
And I'm just going to set it to use our loot_box_stream. And we change this in the target data for the objective. Now when we press play, we can see our current quantity is shown, and when we try to turn in the item, we get a warning that says we have not handled it yet, and this is because we have not set up the function to handle it. To set it up, we just need a reference to our main inventory again, and from it, call the removeInventory event. And just to play it safe, we can also run a haveEnough function beforehand, just to make sure we have what we need before we try to remove it. That way we guarantee that the player is not trying to do something sneaky. Place a branch between the haveEnough and removeInventory calls, using our haveEnough boolean as the value for the condition. Also make sure to hook up the item row name and quantity to remove function. Then finally set handle to true in our return. Press play and try it out. When we turn in the item, we see it removed it from our inventory, and the objective is now completed. The last function we need to set up for our inventory system integration is our isQuestPrerequisiteComplete function. This function is used to control our custom drivers for our quest prerequisites that relate to our connected systems. It looks pretty simple on the surface, but you can easily get carried away in here, so do your best to keep it clean. Let's switch to our quest data table and select the smash time repeatable quest. And for the quest prerequisites section, add an element and take a look at the list of possible keys. The description of each will tell you more about it and provide the syntax that should be used when defining the value. Now the first few relate to quests and are handled internally, and this function we are working in will not be called for them, but everything else on this list is up for you to handle through this isQuestPrerequisiteComplete function. The quest system will call this function during each needed evaluation. Now while we're in the data table, let's select inventory, and for the value, let's just put the row name to an item, loot_box. Defining this is saying we want to make sure the player has at least one loot box in their inventory to make this quest available. Now switch back to our function. And like the other ones, this function is used to handle multiple types of prerequisites, and we can determine which one we are currently evaluating based on the value of our prerequisite type enumeration. Go ahead and hook a switch up to it, and this will provide you with a list of our prerequisite types. Excluding the quest ones at the top, each one of these that you are utilizing in your game will need to perform an evaluation in this step. For multiplayer, keep in mind that this is called on both the server and the client. On the client, it is used when managing indicators as well as when showing certain things in the UI. For the server, it is used to validate and progress the state of our quest and its objectives. In our data table, we defined an inventory prerequisite of loot_box. So let's start here. And what we need to do is check our inventory quantity for the item we entered. So go ahead and drop a reference to your AC_inventory item system, and then a reference to its AC_main_inventory into your graph. From it, call the getQuantity function. For the item row name input, plug in your prerequisite key. Now the value coming through for this, based on our example, will be loot_box. From the quantity, drag off and select greater than or equal. Now in our data table, we didn't specify quantity, but that is okay because if we omit it, we can assume that we just want to treat it as a quantity of 1. And I'll show you how to use a different quantity in a minute, but just for now, when we do define a quantity, it'll come through on our prerequisite value variable. So to account for if it is provided and when it is not, we will use the max integer node. This will select the highest value from the two inputs. We'll use our prerequisite value as our first input, and we'll hard set 1 as our second value. So this way, if we don't define our prerequisite value, it'll default to using 1 instead, which works perfect within our syntax. Go ahead and hook the greater than node to the return node, and then hook the return node up to the switch for inventory. When we press play, we do still see our indicator above our quest, even though we don't have the item in our inventory. And this is because the state of this quest is already set to available. And by default, quest prerequisites are only evaluated while the quest is in the not available state. Now we could use our quest reset button to reset the state of the quest, or delete button to delete all quests for the player. And both of these would force it back to the not available state, which it'll be reevaluated again. And after using a button, we can see that the quest is not available now because we don't have the item in our inventory. And I'm just going to go grab one by the entrance real quick. So now that we have the item, we do see that it's available, but if we drop the item, it's still available. And this is because the state was already changed. So if we want to make sure that the quest is only available while an item is in the inventory, and if we drop it, make it not available. This is where our quest option, reevaluate availability, comes in, which will check the prerequisites again while it is marked as available. And if it fails, it'll take it back to the not available state. Go ahead and enable this option. As we can see, when it starts up, it is available because we do have the loot box in our inventory from the last session. And if we drop the loot box, we see the quest state change to not available. And we pick it back up, it's available again. Let's try something a bit more advanced. Let's say we want to require 2 different items, and one of them we want the player to have at least a quantity of 4. Head back to our data table and update the syntax. First we use commas to separate each item, then we use a colon followed by a number after an item row name to define its quantity. So let's say we want the player to have 1 normal loot box and at least 4 loot box extremes. Here's what the syntax would look like. Go ahead and give it a try. As you can see, nothing extra was needed in our code. This is because the quest system parses our syntax and knows how to handle it. As long as you follow the expected format, it should work. Try dropping either item. It'll only work when you have the exact combination detected. Now, just to point this out, you can optionally define 1 as a quantity if you want to, using the :1 syntax. It's just optional. The way we designed our function, it should handle it either way. Now, a nice thing about this setup is that our hotbar, equipment, and currency all work the exact same way. The only thing that differs is the inventory source. And we can adjust the code we have to account for all of them just by using a select node. And our prerequisite type as our wildcard for the select node. Then for each relevant type, we can hook the appropriate AC inventory reference up to it. For our main inventory, this will be used for our inventory and our currency. For our hotbar, we'll use the AC_main_hotbar. And for equipment, we'll use AC_main_equipment. Also make sure to route each of the paths from our switch in the one that we already have by creating a rewrite node and then hooking them all up. Now making our pawn equip equipment is part of the item system setup. So if you want to try that in this demo world, the quick way to do it is just change the pawn to use the example player character instead. This is the one that's provided by the demo world of the item system. That way you can test the equipment prerequisites if you need. Now back on our data table, we can use the hotbar, equipment, and currency prerequisite types. And the syntax for them works the exact same way as the one we just did. You can get as crazy with it as you need. For example, if we want to have a hidden quest that is only available when we have a smiley helmet equipped, Timmy's egg launch in our hotbar, a loot boxer and loot box extremes in our inventory, and 100 gold, we can do that. Also keep in mind there are a variety of reasons to have something like this, from hidden quests and Easter eggs to offering a way to verify that the player understands the basics of your game at the start, through means like a tutorial where you have them equip and pick up various items from the world. How you design this functionality is entirely up to you. That concludes everything for the item system. Next, we're going to move on to the experience system. Let's start off by adding the experience system to our project. Back in the Epic Launcher, use the vault to find the experience system, then add it to your project. If you get a warning about overwriting files, go ahead and accept it, and if for some reason it fails, close your project, then try adding it again. After adding it to your project, you should see the experience system folder in your content directory. Return to your player controller, then add the AC_experience system to it. This will install the experience system for you. When you press play, you should see the experience bar at the top, and then if you click on it, you should see the experience window. And like our other systems, when we close this window while having another one open, we lose control of the mouse and input, and vice versa. So we're going to fix this first. Back in your controller, right-click on the AC_experience system component, then click the Edit button to open it up. Locate and open the Hide Experience Window function. And right here where it is setting the input and mouse cursor is where we need to check to see if our other systems have anything open first. Let's hook a sequence here and put all that stuff coming out of the then 0, and we'll just have our call UI experience window hide event on the then 1. And just like we did in our other functions, let's go ahead and get a reference to our player controller, then get component by class, and this time select our AC_QuestSystem_player controller. From it, get our quest HUD, and then from that, call our hasAnyOpenUI function. This time we'll leave include external enabled. That way it also checks our item system for us. And it's one less thing we have to account for in here. Create a branch that you hook up to the hasAnyOpenUI function, and then plug it into the then 0 on our sequence. Then coming out of the false node, we want to hook up the previous logic of setting the input and mouse cursor. That way it only runs, nothing else is opened. Press play and try it out. When you close the experience window first, the input does not change and the mouse cursor is still visible for us, which we need for our inventory and quest window. Next, we need to account for it going the other way, where our other windows are closed first. Head back into the UI_QuestSystem_HUD's hasAnyOpenUI function and place a sequence between our two branches. For our inventory system check, have it come out of the then 0. For our experience system, we'll be working out of the then 1. Duplicate the getComponentByClass reference and hook it up to the getPlayerController reference that's already there. For the class in this one, select AC_experience_system. Then from this, get a reference to the UI_experience_window. Right-click on it and convert it to a validated get. Go ahead and hook it into our sequence, and then from its reference, call the isVisible function. Hook the validated get up to a branch, then plug your isVisible return into it. Then coming out of the true path, attach a copy of our return node with the hasOpen window set to true. Now this will resolve the issue when we close our quest window first. Next we have to do the same thing but in our inventory system. By now you should really get a feel for what goes into doing this without using a component to manage all our windows. And perhaps if there is enough interest, maybe I'll make a follow-up tutorial that goes over creating and implementing this window managing component method I keep talking about. I'm going to copy the getComponentByClass through the branch, then head into our UI_itemSystems getWindows using mouse function. Then I'm going to paste everything below the one we have for our quest system. Make sure to hook the getComponentByClass up to the player controller. Also hook the validated get up to the sequence, and then from the true path on the branch, hook it up to the incrementer. Press play and give it a try. Your inventory system should now play nicely with the experience system. Now for the fun parts. Let's start off with our numeric rewards. Back in our quest data tables, I'm going to add a few rewards to our smash time quest. A piece of raw meat, some level experience, and some mining experience sounds good. When we press play and interact with our quest giver, we can see the raw meat, but we don't see our numerics. And this is because we haven't told the quest system how to get the data for our numerics yet, at least for our experience system. Head into your player controller and open the getNumericForQuest function. This is our numeric info function, remember? Drop a copy of your AC experience system component into the graph, then call the getExperienceData function. Hook the numeric row name up to the experience type ID input, then break the data and hook the title up to the name on the return node. Also make sure your isValid is true on the return node. Also make sure to hook the return up to the experience path on the switch. Press play and check the quest window now. There we can see our numeric rewards for player and mining, and these text labels are coming out of the experience data table, so if you want to change them, that's where you'll do so. Next, let's handle the quest rewards for experience. Head back to your giveQuestRewardToPlayer function and drop a copy of your AC experience system reference into the graph. Then from it, drag out and add an experience node. Hook it up to the experience path on the switch. Also make sure to hook the item row name and quantity up to the experience type and amount inputs on the add experience function. And to make this easier, I'm just going to duplicate this ready to turn in button and change its quest to smash time. Then when we press play and jump on it, it'll quickly change our state to ready to turn in. Now we can quickly test receiving our rewards. And when you turn in your quest, you should see your experience added alerts. And also see the experience bar at the top gain some. We can also use our experiences to help drive our quest prerequisites if we like to add level requirements to the availability of our quest. Head into the isQuestPrerequisiteComplete function and drop a copy of your AC_experience system into the graph. From it, call the getLevel function and connect your prerequisite key up to the experience type ID. Then from the return on this function, hook the level node up to a greater than or equal node. Value we're comparing it to will be our prerequisite value variable. Drop in a return node, hook it up to the player level path, and connect the greater than or equal node to the isComplete pin. That's it. Back in our data table, we can define our experience type and level just like we did for inventory items and quantity. The syntax is the same. Now if we add the prerequisite to require level 2 and mining 5, we'll still see our quest since our player is level 2 and our mining is 7. But let's change it to level 3. And now we don't see our quest. Let's create a quick little key binding we can use to boost our experience to see the prerequisite in action. Back in your player controller's event graph, create a key binding for the Q key. Then drop a copy of your AC_experience system reference in the graph and hook an add experience node up to it. Set the experience type to level and the amount to something big like 10,000. Return to the game, and when you press the new key binding, you should be giving your player enough experience points to surpass our requirement of level 3. And at that point, you should see the quest become available to you. And that's it. If you made it this far, you have successfully installed all 3 of these systems together. And if you run into any issues that you can't sort out, or if you have any sort of follow-up questions or ideas for future tutorials to expand on what we covered here, feel free to let me know in the comments. Thanks for watching and good luck with your game.